Hello and welcome. This is Units 2 and 3 Differentiation of AP Calculus AB and BC. This is Part 3 where we're going to be looking at advanced differentiation. Most of the content here shows up in Unit 3 as opposed to Unit 2. And with that, let's get started on some of the rules that we're going to be learning today. Alright, so there are this huge list of rules, but don't get worried, right? There's not that many rules, and they do make some intuitive sense. Alright, so f of g of x is when you take the derivative of that, when you take the derivative of these nested functions, you get f prime of g of x times g prime of x. And this is the one we're going to use the most, right? This is called the chain rule, right? And basically, if we have a function of something else, say, if I were to write, how about e to the 2x? Right, we know that the derivative of e of x, e to the x, is just e to the x. And the derivative of e to the 2x, well, we'd have to do something similar, and it would end up being 2e to the 2x, because we take the derivative of e to the x, and then multiply that by the derivative of 2x, which is 2. Right, so that's a nice example of that, but we are going to get more into depth with these rules. And the next one is the inverse function rule, right? If the inverse function of something, this is then you do 1 over the derivative, the f prime of the inverse of x. Now, most commonly, we use this when we're trying to find like the value at a specific point, right? The derivative at a specific point, because otherwise it becomes kind of difficult to like reverse engineer x, and at that point it's just better to actually convert the function into a function of y, say. Right, now we do have 3 more of these trigonometric inverse functions. Unfortunately, you just have to memorize these. There are derivations, there are proofs for how you get here using a right triangle, but we're not going to go over them. But yeah, the derivative of the inverse sine of x is 1 over the square root 1 minus x squared. The derivative of cosine is the negative of that of the derivative of sine. The derivative of tangent is 1 over 1 plus x squared. So 3 of those you have to memorize, but they don't show up too often, so I think we'll be good. Let's move on. Don't know why that was there. Let's go on to our next question, our first question, and let's see what we can do. So we're asked for the derivative of e to the x times sine to the x. Now we can use the product rule that we used last video, but we didn't really get a chance to utilize it because we now get to utilize it more when we know these advanced rules. That's why we waited. Right, so using this is our first function right here, e to the x. Our second function is sine x. So we take the derivative of e to the x is e to the x sine x. And then we add that to e to the x times the derivative of sine x, which is cosine x. So it's going to end up being e to the x sine x plus e to the x cos x. Let's keep going. Alright, here our first function is x cubed. Our second function is sine x. The derivative of x cubed is 3x squared. So multiply that by sine x. And then we add that to x cubed times the derivative of sine x, cos x. So as you can see, it's not that hard to get into the rhythm of just finding 2 functions, taking the derivative of both. Moving on. Don't know why that's there. Sorry. But here are 2 functions, sine x and x squared. Same drill, right? We do cosec times x squared, and then plus 2x sine x, and that would be our derivative. Alright, another partial request. I'll give you a second to try to work it on your own before we get started on this one. Pause the video if you need to, but we are going to begin right now. Alright, so these are 2 functions, right? Fx and g of x. We take the derivative of the first one, that would be negative sine x, negative sine x times the other function, which is x to the negative 2, x to the negative 2, and then we would add that to the derivative of x to the negative 2. So bring the negative 2 down, and we get negative 2 x to the negative 3 times cosine of x. So the derivative of this function is going to be negative x to the negative 2 times sine of x minus 2x to the negative 3 times cosine of x. That's next. All right, let's keep going. Now we have, now we actually have values for, let's see, g of x, h of x, and then g prime of x, and gh of x. And we have to figure out how to find the derivative of their product at x equals negative 4. So using the product rule, we're going to end up getting g prime of x times h of x plus g of x h prime of x. Alright, now we can just start plugging in numbers. So g prime of x equals at negative 4, that would equal negative 1. Right, just pulling values from the table. H of x would be 3. G prime of x is, g of x, is 2. H prime of x is 5. So that'd be negative 3 plus 10, which would equal 7. And let's keep going. Alright, now we have to use the quotient rule, right? This is kind of the same thing as product rule, except that we flip the middle sign to a negative and we divide by the bottom function squared. Alright, so with this, we'll take e to the x. So the derivative of e to the x is still e to the x times cosine of x. And then we're going to subtract that by e to the x times the derivative of cosine x, which is negative sine x. So that would make it like that, right? Because we're right here, and then we multiply by negative to make that positive, and then we multiply by sine x. So plus sine x. And that would be divided by cos x with the original function in the denominator squared. And this is our derivative. Let's keep going. Alright. Don't know why that keeps popping up. I'm sorry. But now we just get a chance to use our quotient rule again. Right, just write it out the way you're supposed to. So g prime of x times h of x minus g of x h prime of x over h of x squared. Alright, again, we just pull values from the table and we plug them in, right? Not too difficult. This becomes 8. This becomes minus 2. This becomes, what does it become? G of x becomes 7. H prime of x becomes 4. And then h of x is negative 2, so h of x squared becomes 4. So 8 times negative 2 is negative 16. Negative 16, and then subtract 28. It's going to be negative 44. Negative 44. And then divide that by 4 to get, negative 11. And that's our answer. Alright. Now let's keep going. Alright, so we have another instance of the quotient rule, right? Let's do. So the numerator 3x squared plus 1, so derivative of that would be 6x, and then multiply by x plus 2, and then we subtract 3x squared plus 1 times the derivative of the denominator, which should just be 1, so we can exclude that, over x plus 2 squared. Alright, so this will be negative 18. This will be negative 1, right? Just plugging the negative 3 as x. That'll be 18 minus 3x squared would be 27 plus 1 would be 28. And that would be over 1 squared. 1. So that would equal negative 10 as our derivative. Alright. Let's do this one. Alright. So the cotangent of x, we're asked to find the derivative of the cotangent of x, that x equals 5 pi over 6. Now you can memorize the derivative of cotangent. I wouldn't recommend it, but you can. If you do want to memorize it, it is negative cosecant squared of x, I think. But we are going to actually just go through the way it's supposed to be gone through, which is transform it into cos x over sine x, and then use the product and the quotient rule, right? So if we did that, we'd end up with derivative high versus derivative high times low times derivative low times high. So that would be, let's see, negative sine squared x minus cos squared x all over sine squared x. Right, so that would be basically minus 1 minus cotangent squared x. So that'd be negative 1 times 1 plus cotangent squared x, right? And one of our trigonometric Pythagorean identities for trigonometric functions is that 1 plus cotangent squared x is cosecant squared x. That would be negative 1 times cosecant squared x. Is what we have up here. Or that's how we get it, right? We just apply the product rule. But now we have to actually find out what we get when we apply 5 pi over 6. So cosecant is 1 over sine, so this is just going to end up being negative 1 over sine squared x. So sine of x, sine of 5 pi over 6 is going to be 1/2. 1/2 squared is 1/4. And then negative 1 over 1/4 would equal negative 4. That is our answer. Let's move on. Alright, not that way, this way. The derivative of tangent of x at x equals pi. So tangent of x, if you remember from our last video, that would be secant squared x. We can go about finding this in the same way we did in the previous one. Split it into sine x over cos x into the quotient rule. But this one you can memorize. It's kind of simple, right? So why not? So secant squared of x, and then secant squared is, secant is 1 over cosine. So this would be 1 over cosine squared x. And cosine of x, cosine of pi is negative 1. The negative 1 squared is 1, and this would just be 1 over 1. Everyone's favorite quantity, which is just 1. All right, let's keep going. All right, now we're asked to find the derivative of the cosecant of x at x equals 3 pi over 2. All right. Now I can just split this up into 1 over sine x, right? And we can do that whole thing, but I'm going to save you the trouble because we already know how to do that, as we've seen in this one. So I'm going to go ahead and tell you that the derivative of cosecant x is going to be negative cosecant x cotangent x. Right, now it might seem hard to memorize this, but there are some patterns, right? Like up here, when you have, if you multiply the cotangent x by cosecant x squared, you're going to end up with 2 cosecants and 1 cotangent. Same thing here, you're going to end up with 2 cosecants and 1 cotangent, and then the negative sign. Same thing works if you compare tangent and secant, but we won't get into that here. But, I mean, this is the derivative, so we just plug our stuff in. 3 pi over 2 in the negative cosecant x is going to be 1, right? So it's going to be negative times the negative 1 times cotangent of x, which at this point is going to be 1. So this is cotangent cosecant x, cosine x over sine x. Sorry, could not speak words there. And that would be 0 over 1. So it's going to be times 0. And guess what? Anything times 0 is 0. So that is a 0. And that's our derivative. That's our answer. All right. Let's go to some other questions. All right. So we have the g of x equals secant of x. Now, if you remember back here where we had the secant squared x, we're going to use the same principle. You have two secants, one tangent. You want to have two secants, one tangent when you use it here. That's going to be sec x, tan x. And if you multiply this, you get two secants and one tangent. Now, I do want to make clear that this is not like an actual like rule, right? There's like no actual algebraic or calculus basis for why that works that way. It's just a nice pattern. So, I mean, if you just forget about it, which I mean, I wouldn't memorize it personally, but then you can always just use this to find it quickly, and that's why it's nice. But don't take it as like just a set in stone rule, right? Just use it when you need it, but don't like apply it to something that it just shouldn't be applied to. But with that said, let's get on to the question. So we just need to plug in 3 pi over 4 into our equation, right? So secant of x is going to be 1 over cosine of x. Cosine of 3 pi over 4 would be, so if you're thinking about it, it would be like this angle right here, that theta. So the cosine of that would be 1 over the negative 1 over the square root of 2. So here this would be negative square root of 2. And then the tangent would be negative 1. And so our answer would just be the square root of 2. Alright, let's move on. So we're told that function f is defined as 6g of x plus 2h of x minus 1. And we're asked for the derivative of f at negative 2. Alright, so I'll let you try to attempt this from a couple seconds before I show you. Let's see. Alright, so if you need more time, you can always pause the video, but I'm going to move ahead. Alright, so the first thing we should remember is that constants don't affect the derivative. So that minus 1 over there is, I mean, it doesn't matter. It shouldn't be there, right? Because it doesn't do anything. And the next thing is our constant multiple rule, right? We can just pull out the 6. When we take the derivative of g of x, that'd be 6 g prime of x plus 2 h prime of x. And that is our derivative. Right, so that's the derivative of f prime of x, right? And then now we just need to plug in minus 2. So plugging in minus 2 into g prime of x, we get 2. 6 times 2, 12. Plug into h prime of x, we get 8. 2 times 8 is 16. 12 plus 16 is obviously going to be 28. And that is our answer. Let's get on to the next question. Alright, so we're asked for the value of the derivative of this polynomial at a certain point, certain x value. Alright, so I'll let you think about it for a couple seconds, pause it if you need to, and then let's go solve it together. Alright, so we have this polynomial, right? But to find the derivative of it, we can just split it up into its separate parts. So we have one part here, we have another part here, another part here. Take the derivative of all those, we get negative 8x cubed plus 9x squared minus 2x. Alright, then we just plug in the minus 2 as x. minus 2 cubed is going to be minus 8. Minus 8 times minus 8 is 64. Then minus 2 squared is going to be 4. 4 times 36 is 4 times 9 is 36. And then minus 2x. Minus 2 times minus 2 is going to be 4. 4, so that's going to end up just being 104 as our derivative. And we are done with that question. Right, so here is a similar problem. Right? A similar problem, just another polynomial to take the derivative of. I'll give you some time. Right. And alright, let's go and do this. So right, so you know the drill at this point, so I'm not really going to explain every single step of it, but we're just going to go through it. Right, so here we go. Right, plugging in. And our final answer would end up being 96. Alright, and I have another problem, almost exactly the same. Pause the video, use as much time as you want. I'm going to get started. Right, so obviously, right, same drill, same process, not too difficult. So we just here, that. We're not solving for a value this time, so we can just leave it in this form. All right, next, yet another polynomial, right? And yeah, right, we're just trying to make sure we all understand how to take all these derivatives, cut and dry, because this involves the power rule, and if you want to do anything, you need the power rule. So yeah, we're just going to split it up into parts, take the derivative, nothing too complicated about it, and that is our answer. All right, now we are going to get into some non-polynomials, right? So we're asked to find the value of a derivative. Okay, asked to find the value of this derivative of 9 over x cubed over 9 over x cubed plus 1 over x at x equals negative 3. And that's our value, right? So we're going to plug this in at the end. Now, how are we going to go about doing this? Right, so we do have this 9 over x right here. Right, we have 9 over x cubed, and we have 1 over x. Now, if you watch the last two videos, then you'll know that the way that we go about doing this is by transforming these equations into ones that just are something, a constant multiple times x to the something. And since we're dividing by something, it can be written as times the negative of that. So 9 times x to the negative 3 instead of 9 over x cubed. And then plus 1 times x to the negative 1. And from this point on, right, same thing we've been doing, right? So here, the challenge wasn't really taking the derivative, it was more of just figuring out how to get it into a form where we could take the derivative. Right, so to get here, and then negative 3 to the negative 4 is going to be 1 over 81, so it's going to be negative 1/3. And then x to the negative 2, or negative 3 to the negative 2 is going to be 1/9, so minus 1/9. Be negative 4 over. Right, now we have another problem similar to that, right? Figuring out how to transform our equations. I'll give you some time to try to attempt this one. Right, now notice this time we are again plugging in or an x value. We're trying to find out what this function is. Let's take the derivative. Yeah. All right. So should have seen that is 3x to the negative 2 plus x to the negative 1. And that would, of course, give negative 6, x to the negative 3 minus x to the negative 2. So plugging in 3 into that would give negative 2 over 9, because it would be negative 6 over 27. And then you subtract another 1/9, which would be negative 1/3, or sorry, negative 3/9, which is negative 1/3. So negative 1 over 3 is our answer right here. Well, all right, another question. Now we're combining the two different types, right? We have the type where we have the x's on the bottom, denominator, we have to transform them, and then we just have the regular type up here, of course, with our adding, subtracting to split up these different terms, right? Not just multiplying them all together. All right, I'll give you a couple seconds to figure that one out. And I think, yeah, you know the drill at this point. All right, nothing too complicated. We just do this. Transform the equation 2 into, oops, we transform this into 4x minus 3x to the negative 1 plus x to the negative 2. Take the derivative of all this, we get this plus that was not a good 2. And then minus this. And that is our answer, because we're not asked to find the value of it. We're just asked to figure out what it is. Alright, same thing. I don't know why this 1/3 is sticking around in here. Don't know what's going on. Alright, that's weird. Alright, so ignore the 1/3. But we're trying to find the derivative of g of x of 4 over x cubed plus 1 over x plus 2. And we can do that by transforming the equation. I give you some time while I try to figure out what is causing this random thing to happen. Alright. So, you know the drill. 4x to the negative 4 plus x to the negative 1 plus 2. Right, 2 doesn't matter. Everything else becomes negative 16, x to the negative 5 minus x to the negative 2. And there is our answer. Right, let's keep going. Alright, now we actually have some words and a problem, right, instead of just a bunch of numbers, right? So we're asked for the equation of the tangent line to the graph of this function at the point x equals 3. Well, the equation of the tangent line, that means we want to find the derivative. That's going to be the slope. And then we just need to find a point, right? So what we're going to do is we're going to find the derivative of f. We're going to find derivative of f prime of x. F prime of x is going to be negative 3x squared plus 8x. So f prime of 3 is going to be negative 3 times 9 plus 24. It's going to be negative 3. So our equation is then y equals negative 3x as our slope. And then we need to have some constant. And we figure out that constant by finding a point. And that point, well, that could be x equals 3. So we plug in x equals 3. We get negative 27 up here. Negative 27 plus 3 squared is 9 plus 4. That's going to be 36. And that's going to be 9. So we plug in, we get y equals negative 9 plus c. That's supposed to equal 9. So then c, therefore, is going to end up being 18. And the equation of our tangent line is y equals negative 3x plus 18. And that is our last problem. Alright, I hope you enjoyed this video. I hope you found it informative, and I hope you learned something. This is the last video in our three-part series about Units 2 and 3. Well, next we'll be back with a series about Units 4 and 5, which are the applications of these differentiations, right? More word problems instead of just finding derivatives. Until then, I'll see you next time.